welcome back. This is part 3 of transformations, and we're looking in this section at rotations. So a rotation is a transformation in which a figure turns around a point called the center of rotation. So rotation is just a fancy word for a turn. So I want to talk about the center of rotation for a minute. In this example, they're using the origin, or the 0, 0 point of this coordinate grid, as the center of rotation. So what that basically means is if you could put a pin through that point, or put your finger very firmly on that point, and not let that part of the paper turn, but turn the rest of the paper around, that's the point that doesn't turn. So it's kind of like the sun in our solar system. The sun moves throughout our galaxy and throughout space, but in our solar system, the sun is the stationary point and the rest of the planets rotate around the sun. That's kind of that general idea. So let me show you just a couple of examples. This point right here is the center of rotation. I have this triangle here. So I could rotate that triangle 90 degrees, 180 degrees, 270 degrees. That was 3 90-degree turns. And then if I do the fourth 90-degree turn, I'm right back at the original point. So 360 degrees. You know, if you do a 360, you haven't actually gone anywhere. That was with the center of rotation right here. And you can see how we can move that triangle, rotate that triangle around the center of rotation. I can move the center of rotation so that it's, for example, maybe right here. And then when we rotate, that's the point that stays still, and the triangle rotates around that point. Again, imagine that you could put your finger right there on that point, hold the paper steady, or put a pin or a nail through that point so that it can't possibly move. And then you just rotate the figure around. Or we could even move the center of rotation right onto the shape itself. So again, this is the point that's not going to move. That point right there is going to stay exactly where it is, and the shape, the rest of the shape is going to rotate around that point. Okay, so we can put it way over here, and then we can rotate triangle. Now it's going to have it much, it's going to go right out of our picture there. So that's just a basic idea about the center of rotation. Okay. In 7th grade, your center of rotation is always going to be the origin. They're not going to ask you to do something complicated like this point or this point right here. So we don't really have to worry about that in 7th grade. And again, they're using those prime markings. This is triangle RST has been rotated about the origin to triangle R prime, S prime, T prime. So you can see that point S was really close to the origin. It's still close to the origin. It just rotated over to this point. T was farther away, and it's still farther away. It's just rotated down to this point over here. So these are a little more complicated. I'm going to show you 2 pretty simple methods that'll help. So let's go right about here. All right. Let's take a look at the question. It says that they need us to graph the image of triangle FGH. So here it is, FGH. After a rotation 90 degrees clockwise around the origin. So there's that around the origin that tells us this is our center point. Makes our job much, much easier. Clockwise. What does clockwise mean? Well, clockwise means that we're going to be going the same direction as the hands of a clock. I know you don't have to draw the clock on your paper, but the clock hands would travel in this direction. So 12, 1, 2, 3, 4. So that means that we're going to be rotating the shape in this direction. Okay, the same way that the hands of the clock would travel. 90 degrees means that I'm going to be making 1/4 turn. You see that this is 90 degrees right here? That's 1/4 of a turn. If they asked me to do 180 degrees, that would be 2/4 of a turn. So 1/2 of a turn. So this one is a 90-degree clockwise turn. That means it's going from this quadrant, which is quadrant 1, to which quadrant? Which quadrant is it going to end up in? 90-degree clockwise, I hope you were thinking quadrant 4. 90 degrees clockwise, it's 1/4 turn in this direction, so it's going to end up somewhere down here in quadrant 4. So let's go ahead and cross out quadrants 2 and 3, because our answer is not going to be in those quadrants. All right, so I'm going to get rid of this clock so I have a little room to write. Now, let's start with let's start with point F. One method that we have is to look at the current location of point F. And right now, F is at 1, 7. Remember, we always read the x value first and then the y value. So right now, it's at 1, 7. When you do a rotation, you're going to sometimes swap those two numbers, so it might become 7, 1. Sometimes one of the numbers is going to change sign, so maybe it could become -1 or -7. Or they could swap sides and change signs. So let's take a look at what two of our options are. We know that we're going to be down here in this quadrant, okay? So when we make that 90-degree turn, we could either end up with 7, -1, which might be this point right here, or 1, -7. Those are the only two options we have using 1 and 7. Well, don't write these on your paper. Let's just look, maybe make a little pencil mark at that point right there and that point right there. Those are our two possibilities, 7, -1 and 1, -7. They're the only two possibilities in quadrant 4 using the numbers 7 and 1. Well, it's got to be either this point or this point. When I look at this point down here, I notice that this point is actually a reflection of my original point F. You see how it still has the same x value? It still has an x value of 1. So it's actually a reflection of point F and not a rotation. So we know that this point down here isn't the one we want. So I'm going to go ahead and erase that. I'm going to mark these two with the same color highlighter. So point F is going to rotate over to this point, which is actually point 7, -1. So you can see that when we did that turn, the 7 and the 1 had to trade places. And then because we were down here in quadrant 4, the x value is positive and all the y values are negative. So we have +7 and -1. This is the x value, this is the y value. Let's try that on our next point. From the next point, let's do point G. And point G right now is at 9, 7. So when we rotate that 190-degree turn, looking at our example up here for F, we know that we have to trade places, 7 and 9. And we can look at this example and realize that it was the y value that was negative. Or we could look down here and remember that all of the x values in this quadrant are positive and all of the y values are negative. So that means that point G is going to move to 7, -9. And that's starting to make sense. You see this line that would be formed between the green and the blue dots was this line up here, and it's rotated 90 degrees. So let's do the last point, point H. So point H currently is located at 2, 3. And we've seen from our other 2 points that the two numbers, the x and the y values, are going to trade places, and that the y value is going to be negative. So we can put point H at 3, -2. And that looks like we've formed a triangle that looks congruent to this triangle. So let's go ahead and connect the lines. Remember to use your straight edge and your pencil. And there you go. Let's take a look at another example. Okay, this one says to graph the image of rectangle BCDE after a rotation 180 degrees counterclockwise around the origin. So again, the origin is our center of rotation. So we're going to pretend that we could put a pin right in that spot, keep it from moving, and we're going to turn the whole thing around. Now this time it says counterclockwise, so make sure you're paying attention to that. What does counterclockwise mean? Well, counterclockwise means we're going against the direction of the clock. So like my backwards clock we have here, we're going to be going back in time. So we're going to move in this direction. So we're going to be going counterclockwise. All right, now they've asked us to do a 180-degree rotation. Well, 180 degrees is 2 90-degree turns. So we're going to be going from this quadrant, 1, 2 90-degree turns. That means my image is going to end up here in quadrant 2. So I'm going to put an X in quadrant 1 and quadrant 3. Get rid of that real quick. Okay. So let's start with point B. And point B is located at 4, -8. When we do one 90-degree turn up into this quadrant, quadrant 1, which is not where we're going to stay, but we're going to think about that move first. Remember that they would trade places, so the 8's going to go over here, and the 4 is going to go over there. And when you look at quadrant 1, all the x values are positive, all the y values are positive, so we can just leave it +8 and +4. But we're not done yet. We need to do a second 90-degree turn. So when we do the next 90-degree turn, what's going to happen to those two numbers? They're going to trade places again. Now this time, the x values are the ones that are negative, because now we're over here in quadrant 2. All of the x values are negative, so we're going to make this -4. And all of the y values are positive, so we're going to leave that +8. So if we kind of eliminate the middleman, because we really didn't use that step, it was just sort of a step, in-between point, you can see that the 4 is still in the x position, but it's now a -4. And the -8 has become +8. Okay, so that's going to make the rest of the points a little bit easier now that we've noticed that pattern. So I'm going to take point B, and move it from 4, negative 8 to negative 4, 8. And then point C, let's go ahead and jot this down. Point C, separate those, is right now at point 9, negative 8. So let's go ahead and skip the middleman, because we know that the numbers are going to stay in the same spots, but they're both going to change signs. So that becomes negative 9, and that becomes positive 8. So we should actually label this. This is B prime, and this is C prime. So I'm going to move C prime to negative 9, 8. So one of the kids asked me, if Optimus Prime looks in the mirror, does he see Optimus? With Optimus and Optimus Prime, there's another math joke for you. All right, let's move on. We've got point D. And right now, point D is at, let's see, 9 and negative 5. And we know that when we move from D to D prime, that they're going to just change their signs, negative 9 and positive 5. So we can take point D and make it at negative 9, positive 5. And the last point, point E. Right now, E is at X value is 4, Y value is negative 5, so 4, negative 5. And when I do my two 90-degree turns, or my 180-degree turn, E prime is going to just change the signs, negative 4 and positive 5. So that means E prime is at negative 4, positive 5. I like plotting each point separately. Now that I've plotted each point separately, I can compare those 4 points to the 4 original points that I had. And you can see that these two rectangles are exactly the same. You see how this was 1 unit away on this side, on the right side? The rotation is 1 unit away on the left side. There are 2 units down here on the bottom, and there are 2 units up here on the top. So you can see that it has rotated 180 degrees the other direction. So I'm going to take my straight edge of my pencil and just connect the dots. All right, so I want you to put your pencils down. I just want to show you a couple of kind of cool things about these rotations. If you were to take each of these points, so B and B prime, and make a line that goes from B to B prime through the origin. Do you see how it makes a straight line? And that's a 180-degree angle right here, 180 degrees. So the same thing, if we do the same thing with C to C prime through the origin, it's a 180-degree angle. D to D prime through the origin, 180-degree angle. And E to E prime through the origin, makes a 180-degree angle. It's kind of nifty. If we go back up to this example, if we take F, we draw a line from F to the origin. Let me change so I don't have an arrow on there. Let's see, how about this one? If we go from F, oh my, to the origin, and then from the origin to F prime, that's not F prime. I've got the wrong one. F was my green one. Here's F prime. Okay. From F to F prime going through the origin, you see how we made a 90-degree angle? There's our 90-degree rotation. Let me show you again with a different one. Yeah, I'll use this skinnier arrow here. Let's see, from G to the origin, and then from the origin to G prime. See that 90-degree angle right there? And then again with H, if we go from H to the origin, and then to H prime, we made another 90-degree angle. I've got one more trick for you. Here's another way that you could do this exact same problem. See how we have B, C, D, and E? They've asked us to do a 180-degree counterclockwise rotation around the origin. So if you can take your paper, take your whole paper, and rotate it 180 degrees counterclockwise. So there's one 90-degree turn, and there's my second 90-degree turn right there. Okay, so now your paper is actually upside down. You're going to write down, this will be the new location of that image after you rotate it to the new spot. So we're just going to take a pencil and we're going to jot down the new locations of our points. B prime in its new spot would be, we kind of have to think about this, this would be -4 and +8. So -4, 8, you can write that down. And then C prime is located at -9, 8, -9, 8. D prime is located at -9, let's see, 5, -9, 5. And then E prime is going to be at -4, 5. So -4, 5. I can see these pairs of numbers, which makes sense because this is a rectangle, right? So they're going to have some similar points. So now what you do is you take your paper and you turn it back right side up. And then you take your pencil and you plot all these points. -4, 8, -4, 8. This is actually, we should probably label it right here, B prime. -9, 8, -9, 8. This is C prime. -9, 5, -9, 5. So there's D prime. And then E prime is -4, 5. So that's E prime. And then just like before, you just take your straight edge and your pencil, you connect the 4 points. And you have now rotated B, C, D, E 180 degrees counterclockwise around the origin. So there you go. All right, I hope you enjoyed these videos, and I will see you in class.